Okay, we're back. My wife called me, so I had to take that real quick, my bad. And we are going to get started on this again. So when you get to these things, one of the first things you should do is to see if you can factor and simplify anything. Because if you can, then it's going to make a whole. But that's only if you factor and simplify. So more than likely this is going to be factorial, so I'll put my parentheses there. So I'm looking for something that multiplies to negative 24 and adds up to 2. So the things that multiply to 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6, and that's it. Okay, so of these options, there are 2 that will get you the number 2, and that is 4 and 6. In order to get a positive 2, the negative 4 would have to be negative. So you get negative 4 and a plus 6. So x minus 4 and x plus 6. And it looks like right now nothing cancels. Awesome. If nothing cancels, that means there's no hole. That means we do not have to graph a hole. Vertical asymptotes. Vertical asymptotes happen when the bottom equals 0. So let's go see if the bottom is equal to 0, what happens? If you set the bottom equal to 0, you would add 1 to both sides and get x equals 1. So there you go. Vertical asymptote at x equals 1. So I'll go ahead and draw that. Vertical at x equals 1. Horizontal. Horizontal asymptote's the really fun one where you get to compare the degrees on top and bottom. So like up top, the highest exponent's 2, and on bottom, the highest exponent's 1. So it looks like you have an x squared over no x squared. So there's a trick you could do. Like you can think of this as a 1x squared over a 0x squared. And if you do, you're supposed to divide the coefficients, because that's the whole horizontal asymptote. You divide the coefficients. So 1 over 0 is undefined, which means there is going to be none here again to graph. Or you could have memorized that if the degree is bigger on top, there's none. But regardless, horizontal asymptote is the one where you compare degrees. So I'll write myself a little note there. Slant. Slant asymptotes happens if the degree is 1 bigger on top. So we'll see. The degree is in fact 1 bigger on top. So there is going to be a slant asymptote, but I am going to do that last because I feel like it. X-intercept. For x-intercepts, usually you make y equal to 0, but that's the same thing as saying the top equals 0. Because if the top is 0, then the whole thing will be 0, right? If the top is 0, then 0 divided by anything is 0. So all we care about is the top. If the top is 0, then y is 0, and everything is good and golden. So here we had x minus 4 equals 0, and x plus 6 equals 0. Since there's 2 things on top, we're going to have 2 x-intercepts. So if x minus 4 equals 0, and x plus 6 equals 0, then we would add 4 to get x equals 4, or subtract 6 to get x equals negative 6. So our intercepts will be at 4, 0, and negative 6, 0. So 4, 0, and negative 6, 0. Okay. Y-intercept. For y-intercept, you make x equal to 0. So you go up here, and if x is 0, then x squared is 0, 2x is 0, and you just end up with negative 24. So if x is 0, just remember, if x is 0, all 3 of these just kind of are nothing. So you only get this part, which is negative 24 over negative 1, which is equal to positive 24. So 0, 24. Which obviously is off the charts, so I'm not going to graph it. All right, so now we'll go forth and do the actual slant asymptote. So what you have to do for this is long division. X minus 1 going into x squared plus 2x minus 24. Long division like that. The other alternative is to do synthetic division. Long division. The other thing you can do is synthetic division. You can do synthetic division when it's just like a regular x here instead of like a 2x. Like a 3x over 4 or something. But the coefficient's just one, you can do this synthetic division thing where I'll just write it again so you can see. This is the actual question in the beginning. Excuse the interruption. There are people talking on the announcements, and we'll continue in a couple of seconds. There we go. What you can do is use synthetic division by saying, well, if you're dividing by x minus 1, then its quote-unquote solution would be positive 1, and we'll do synthetic division. You then take the coefficients, or the numbers in front. That would be a 1, a 2, and a negative 24, and do synthetic division. In which case, the steps are to drop it, and then multiply it, and then add. So it's drop, multiply, and add, and then and add, and multiply, and add, etc. So dropped it, multiply, add, multiply, and add, and you get negative 21. This negative 21 is a remainder. You should always get a number here that's not 0. If it's 0, you did something wrong. But there should always be something left over, and it should always never matter. All that matters is these things right here. This is going to be your line. What this means is it is 1x plus 3. You know, this is just a number, this is an x, and that was positive. So our asymptote is going to be y equals x plus 3, which I can then go up here and write y equals x plus 3. It is in slope-intercept form, which means that its interception is at positive 3, so 1, 2, 3, put a point there, and its slope is 1, so you'll go up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1, etc., 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 etc. Did I mention etc.? Okay, so there's the asymptote, and here's the other asymptote just for clarity. Okay. Okay, I guess there you go. Doing this whole graph kind of makes the table moot because it says plot at least 1 point on each side. Well, guess what? I already did. Here's a point on this side, so it's 4, 0. Ta-da! Here's negative 6, 0. Ta-da! I have plotted at least 1 point on each side of the vertical asymptote, so I'm just going to kind of go like this. Boom, boom. Awesome. It's beautiful, isn't it? Don't answer that. So domain will be negative infinity to 1, union 1 to infinity. And for range, it goes down forever and up forever. That means there's no like restrictions or anything. It's just going to be all real numbers for here. And that's it. If you felt like it, just like on the previous page, you could write for domain x does not equal 1. But that's by your choice. All range is all real numbers or negative infinity to infinity, whichever. There you go. Okay, so that's that problem. I think we only got one left. Whew. How much do you want to bet there's a hole in this one because the previous one didn't? Let's find out. Factoring. This has a GCF. 2 goes into them. X goes into them. Take out a 2x. You got an x plus 3. On the bottom, multiplies to 3 and adds up to 4. There's only one thing that multiplies to 3. And that's 1 and 3. Hey, look. My prediction came true. x plus 3's will cancel, and because they're canceled, there will be a hole. Simplified, that's going to be a 2x on top and an x plus 1 on bottom. So the hole, what canceled was x plus 3. Because x plus 3 is what canceled, you set that equal to 0, and that's going to be where the hole is, -3. So whatever cancels, set it equal to 0, and that's where the hole is. Just keep in mind, -3 is not a point, it's somewhat of a place. In order to find how far up or down you're supposed to go, you plug it back into here. So if you plug in -3, you would get 2 times -3 over -3 plus 1, which you solve. That'll be -6 over -2, which is +3, it looks like. Okay, so -3, +3, that is a hole. There we go. It's a hole, so I'll draw a circle there. Don't know why I was trying to fill in a dot. It is an open circle, because that's what a hole looks like. Keep in mind, for everything else now, we're going to be using the simplified version. We're not really going to look over here again too much. So vertical asymptote. Do you remember how to find a vertical asymptote? It is where you set the bottom equal to 0. So if x plus 1 equals 0, you get x equals -1. Keep in mind, we are using the simplified version now on. Horizontal, you compare them. So this we have a 2x and this we have an x. The degrees are the same. If the degrees are the same, because they're both to the first power, you divide the leading coefficients. So this is a 2 over 1. So 2 over 1 is 2. So I forgot to graph these. X equals -1. Y equals 2. Oblique asymptote happens when the degree is 1 bigger on top. It is not 1 bigger on top because they were the same, so this is none. X-intercept. X-intercept is where you set the top equal to 0. In this case, it was 2x equals 0. Back from up here, 2x equals 0. And if you divide by 2, you just get x equals 0. So the intercept will be at 0, 0. For the y-intercept, you make x equal to 0. So if you have 2x over x plus 1 and you plug in 0, well, it's not going to be very entertaining. It's just going to be 0 over 1, which is 0. Which is something we've already plotted. Spoiler. So we've already plotted 1 point on this side of the vertical asymptote. One kind of thing you can do that usually works, not always, but usually, is like if there's a point here, if you go like up 2 and over 1, you get to this point. That means there's probably one on the other side of it as well. Kind of like if you go symmetric to it, 1, 2, 1, 1, 2, 1. There's probably a point at -2, so I'll try -2, see what happens. That would be 2 times -2 over -2 plus 1. Let's just plug in a number. That would be -4 over 1, which is -4. Which, I don't know, I might have done something wrong. Yeah, I did do something wrong. This is supposed to be negative, so that's supposed to be plus, which makes sense now. So I plugged in that, I got +4, so -2, +4. There is a point there. Awesome. I have plotted 1 point on each side, which is the bare minimum I have to do, which means that's exactly what I'm going to do. So there's this point. This is going to have to go through this point, go to that hole, and past that hole, and that'll be the answer. Yay! Is everyone happy? I want this to be less than 15 minutes, so have a good one. Bye.